Hi everyone, Onimorin here, and today I've got a pretty unusual pair on my workbench. On one side we have an ASUS ROG Flow X16 laptop, and on the other is the ROG XG Mobile external GPU with an RTX 3080. As for the laptop, it had a keyboard issue. Some keys weren't working at all, but we are not going to focus on that today because it's already been repaired, and you can find that process on my Instagram and TikTok. In this video we're focusing on GPU, and this is where things start to get interesting, you'll see. The graphics card showed no signs of life at all, no reaction, no fan spin, nothing. So I started with the basic, checking the power supply. At this stage I set my multimeter to measure voltage and connected the power supply through a light bulb. This acts as a current limiter and protects the device in the case of a short circuit. Then I powered it on and checked the readings. And now, as you can see, we're getting only around 0.18 volts, while it should be 20 volts. So clearly something is wrong. Our next step, I removed the metal chute from the power supply to access the board. Normally these chutes are not soldered, but in this case it actually was. Once the chute was off, I moved on to checking the capacitors, starting with the largest one. And here's something important, it was still charged, showing around 184 volts. At this level safety is critical, so before doing anything else, I used a capacitor discharge pen to safely discharge it. Only after that could I safely remove it. And as you can see, it wasn't the only one. We had 3 more capacitors on the board. So I removed all of them and started testing. For that I used an LCR meter, which allows me to measure capacitance, ESR, equivalent series resistance, and other parameters. The largest capacitor showed an ESR of around 170 milliohms, which is acceptable for this type. Most of the others were also within good range. However, one of them had significantly reduced capacitance and elevated ESR, which clearly means it needs to be replaced. Exactly this one. After all measurements, it was clear. Free capacitor was still in good condition and could be reused, but this one had to go. So I ordered a replacement, and here it is. Now I reconnected the power supply again through the light bulb, and this time without any load. I probed the output and checked the voltage, and now look at that, it's back, stable 20 volts. So in this case the culprit turned out to be one small, seemingly insignificant capacitor. But that's not the end of the story. Now that we have a stable 20 volts output, I connected the load, the GPU board, and plugged everything back into the laptop. And still nothing. So now it's time for proper board level diagnostics. First step, thorough cleaning, removing thermal paste and preparing the board for measurements. I also get a lot of questions about the tools I use, thermal camera, multimeters. So here's a quick look at my setup. A full breakdown will be in a separate video. And now, since the voltage drops completely when the GPU is connected, there are 2 main possibilities. Either the overcurrent protection is triggering, or the card isn't receiving a proper power on signal. I performed a full setup of measurements. The power input section looked fine, and most coils were okay, but not all. The coils responsible for VRAM and the main power rail showed abnormal values, and this is where things got really interesting. Here I'm showing the 3 coils that raise concern. After more detailed measurements, I found something very telling. The main power rail right after the MOSFET and current sense resistor had low resistance, but not a direct short. Then I checked the VRAM coils and they had exactly the same reduced resistance. That's a big red flag. A quick test confirmed it. There is effectively a direct connection between the main power rail around 20 volts and the VRAM rail around 1 volt. In simple terms, high voltage is going where it absolutely shouldn't, and that explains why the system refuses to start. You can also see on the thermal camera that all memory chips are heating up, which aligns with what we found during the short test. Right here, look at that. So at this point the situation was clear. I contacted the client and explained everything in detail. Because the main power rail fed directly into the VRAM section, there is very high chance that some, if not all, memory chips are damaged and would need replacement. Unfortunately, that makes the repair economically unjustified, so the client decided to not proceed. And this is a perfect example of the repair that doesn't always end in success. From my side, I made sure the card was cleaned and left in the best possible condition for any future work. And with that, we're wrapping up this video. See you in the next repair.